So the reason that we call this webinar and so it fit to have it is because for a long period of time, we've known that Africa has a very high estimated wind energy potential of around 59,000 gigawatts. That's a lot. And even though we have all that much potential, we find that only about 0.01%, a figure of around 6.3 gigawatts, is what we actually use to produce wind energy in this continent, which is very little. And we need to harness even more and more wind energy that can solve the climate crisis, reduce the emissions from fossil fuels, and all that. And as we are gathered here today, we are sitting on the backdrop of the COP28 that is going on in Dubai. And it is worthwhile, even as we continue and we reflect on how Malawi is harnessing the wind energy for a greener future, we need to see how the continent and the world in general is working towards achievement of a transition towards renewable energy. So there are some resolutions that have actually come up within the COP28, and one is the energy transition change makers, which is an initiative started by the COP28 presidency, seeking to fund innovative projects that help to fasten the transition from fossil fuels to clean energy in the hope of achieving a clean power breakthrough by 2030. And basically what this breakthrough seeks to do is one, increase solar and wind power up to 40% of the energy mix in the world, with at least 60% of all the power generation coming from renewable energy sources. And I think there are also a few countries that, a total of 123, that have signed an agreement called the Global Renewables and Energy Efficiency Pledge, which basically is driven to eliminate, which aims to eliminate the CO2 emissions emitting fossil fuels from the global energy system. But we find that these are just writings on paper that have been put there for us to implement in the future. But currently, we have someone who's actually doing the work on the ground, implementing these technologies, making the change that we deserve, with the hope of now expanding this to a larger group. So today we are joined by our speaker, Madalisto Chimpeni, who is the founder of Pepu Energy in Malawi. And I'll introduce him and ask him to introduce himself and just tell us a little bit about Pepu Energy and who he is. Madalisto.
Just give me a second. Good afternoon, everyone. I hope all of you can hear me.
Yes, we can, Madalisto.
Okay. I am Madalisto Penny. I am from Malawi. I am an energy entrepreneur and an innovator with about 5 years of experience working in the energy sector. I've worked about 4 years in clean cooking, dealing with clean fuels for cooking, specifically biogas, bioethanol, and briquettes. And then I pivoted and then founded Pepu Energy, which is a Malawi-based startup that is pioneering wind energy with the intention to provide electricity to rural communities across the country. So we collaborated with an Argentine partner and we developed a novel helix wind turbine. We call it a helix wind turbine. It's a sort of unconventional design from the common three rotor blade that you see, the one with 3 spikes. So it's totally different from that one. I think I'm going to give more explanations on the technology in the presentation. So yeah, that's about me. I can't hear you.
Thank you so much, Madalisto, for your contribution to the energy sector. We already know that it's going to be sort of engaging with all those things that you've done in the clean energy sector. So now I'm going to request Ian to share your presentation so that you can get us going. And once that is done, we can engage in more discussions and hopefully learn a little bit more on the wind energy landscape in Malawi. Ian?
So again, good afternoon, everyone. I'm Medicine Benny. I'm the founder of Bebu Energy. I work with Steve Malimia. I'm sure Ian met him. Ian met him when he came to Malawi. So we are partners in this. We've been working together for about a year now. But I've been prototyping this technology for about 2 years, and I'm literally one step away to producing a final product that can be deployed on the market. So what inspired me to start Bebu Energy? Can we move to the next slide? Malawi is one of the least electrified countries globally. It has a connectivity of about 19%, with 81% of the population without access to electricity. So if you do the math, that's about 15 to 16% of the population that does not have electricity in the country. So that's a huge challenge. And the biggest challenge is that we are very reliant on hydroelectricity. We don't have an energy mix that includes maybe a lot of percentage of solar as well as wind energy and other sources of electricity. We do have a bit of solar energy, but it's the percentage is very negligent if you compare it to the power that's generated solely from hydro. Let's move to the next slide. So I collaborated with an Argentine partner by the name of Eduardo Garcia, and initially he developed a technology that was efficient for hydroelectricity. We're actually still working on that technology, and at this moment we are in an agreement with an entity from the UK to actually start mass producing the turbine and exporting it to the UK. I'm pretty sure that's going to start maybe next year. But let's get back to the Helix wind turbine. So this was developed as a divergent design from the turbine that was patented from Argentina. So this one has a single spiral blade on the horizontal axis. It's made with fiberglass, composite, and steel. And the advantage of this technology is that it's capable of generating electricity at low altitudes and low wind speeds, unlike the conventional wind turbines that you see, the big ones. Those ones are built for high wind speed areas. But what if you have areas that do not have the required speed of wind to make those wind turbines efficient? What are you going to do? You still have a lot of wind in that area. So that's why I come in with my technology, the Helix wind turbine. You install this somewhere at somewhere just a height above 1 meter. You can generate substantial electricity to electrify a rural community. Let's move to the next slide. So development started really slow. I think this is something I made last year. I made that turbine with steel and plastic paper. So the whole turbine was covered with plastic paper. That's basically because we had a challenge with finding the right materials to do it, and we're working on a budget. So that is the first prototype that I built. It was pretty big, but we managed to compete in a competition in Malawi design. In the Malawi Innovator Design Competition, we actually won a prize, which is quite surprising because it was a really bad design, but the judges saw that it had the potential to become something. So moving on, we improved it and gave it a turbine. We gave the turbine the fiberglass structure, So that's the fiberglass structure on the right. Let's move to the next slide. Yeah, so that's me painting the turbine as well. And this is what it looks like at the very end, with a generator mounted on it. I do have videos showing how it works when it spins on the wind, but uh, maybe I'll share with you some other time. I'll just throw in a link so we can see exactly how it works. So that's the Helix wind turbine, and we're currently at the very prototyping phase of the project. And luckily enough, we've actually enrolled in an incubation program that improves ideas like this to from a prototype to a market ready product. So we're looking to have this thing finalized by February or March. We're going to have something that we can deploy on the market. Let's move to the next slide. Yeah, so looking at Malawi's wind energy landscape, like I mentioned, over 80% of the country's electricity is generated from hydropower. Malawi has mean wind speeds of between 5.6 meters per second to 6.4 meters per second, which is not the most desirable mean wind speeds, but it's okay to generate electricity with. You can actually generate a substantial amount of electricity with these mean wind speeds. So as you can see on the map, is the northern part of the country, which is red. It has the highest potential to generate to capture energy from wind, with a technical potential of about 50 megawatts or more. But that's the data that I collected from a company that's actually doing a feasibility up north. We have some parts of the central Malawi that have favorable wind speeds for electricity for generating wind power as well, and also the southern part of Malawi, called the Sierra Highlands. It's a place where you can actually generate substantial amount of wind power. Let's move to the next slide. Yeah, so basically, what the role of wind energy can have on energy transition in Africa, uh, cannot be measured. It's very vast. You're talking about replacing fossil fuels in power generation, increasing connectivity, creating an enabling environment for adoption of clean technologies. Um, as we can all talk about the energy transition, we're currently in the phase of the coalition of parties. There's a like the moderator talked about it. So in this case, wind power has the potential to replace these fossil fuels. Uh, since wind power is clean, it's a renewable source of electricity as compared to fossil fuels that produce a lot of carbon emissions into the atmosphere. So it's still a challenge because now to downscale the cost of installing wind power in Africa uh, is challenging because we have to import all the materials into our countries. We have to import fiberglass. We have to import the turbine blades. We have to import the what's this? The support platforms for the turbines as well. So this actually makes it more expensive to implement these energy projects in Africa as compared to coal. Coal can actually be mined everywhere. We have coal everywhere that can actually be mined, and then you set up a plant and then you generate electricity with coal. But as technology keeps on advancing, uh, these technologies are downscaling in the cost, in the prices as well. So in the next 2 to 5 years, we're going to have wind technology that is actually very cheap as compared to fossil fuels. So in the sense that you can actually literally replace these fossil fuels with wind energy as well as solar energy as well. It's also scaling down. So there's another issue of increasing connectivity. As we all know that Africa is one of the least electrified region in in the world. About 600 million people do not have access to grid electricity, and this actually forces them to rely on biomass fuels as well as fossil fuels for lighting and cooking. So wind electricity actually bridges this gap by decentralizing access to electricity. So instead of having these big power plants that you install and then transmit electricity to rural communities, we can cut those off and then install these mini grids where you improve connectivity in rural communities and then provide electricity where they can use for cooking and lighting to reduce the carbon footprint of cooking as well as deforestation in rural communities, which is one of the major factors that increase the chances of climate change. The other issue is creating an enabling environment for the adoption of clean technologies. Clean technologies, for instance, electric mobility. So if you have an energy mix, if you have solar energy, if you have solar energy, wind energy, if you have what's this uh, nuclear energy, let's say hydropower in the mix, you increase the chances of creating an environment where you can adopt technologies like electric mobility for replacing fossil fuel driven cars. So these are just basically the roles that wind energy can play in Africa's energy transition, in the mitigation of climate change as well as adaptation. Let's move to the next slide. So I wanted to talk about the innovations in wind energy. Innovations in wind energy that can improve access to electricity in rural communities. So like I mentioned, the three-rotor blade design is not, it is very effective, but it is not adaptable design for anywhere in the world. They need specific places where you can generate electricity with high wind speeds. There are innovations that have been developed that are adaptable and capable of generating electricity in places where you have huge obstacles, like buildings, trees, mountains, in places where you don't need a lot of investment into infrastructure for supporting the turbines to generate substantial electricity. So we have vertical axis wind turbines. We have Savonius wind turbines. We also have Archimedes wind turbine. It's like a variation of the wind turbine that I'm working on. The Archimedes wind turbine. It's sort of a different design, but they work on the same principle. So a lot of these innovations can be scaled down. You can have a standalone installation on a on top of a roof, or you can just put a support platform that's about 10 meters above the ground, and that's very affordable compared to something that you need maybe 50 meters above the ground. So these are just examples of wind turbines that can be installed at a lower cost and that can be distributed up in a wider range of areas as compared to the conventional three-rotor blade design that we generally see on televisions, and I think they also have them in Kenya and South Africa as well. So let's move to the next slide. Now, to talk about the key challenges, the biggest challenges in the adoption of wind energy in Africa. I think the first challenge that I highlighted is the lack of infrastructure. I think there's also one thing that I think I wrote. Okay. Anyway, the lack of infrastructure. The lack of infrastructure is actually a huge obstacle. We don't have the facilities that can produce these turbines. We cannot manufacture these turbines on our own. We cannot manufacture electric motors. We cannot manufacture gears, generators. We cannot manufacture these supporting platforms for the turbines. So we lack the infrastructure to enable us to build these technologies ourselves. So we rely mostly on importing the turbines from, let's say, China or USA, which is very expensive. It comes at a cost importing as well as taxes that come with transportation as well as taxes that come with importing technologies. Another challenge is the lack of technical know-how. I think this is also the biggest challenge that I faced in Malawi when I was working on wind energy. We don't have a specific course, a program that teaches uh, at any university that provides the technical capacity to build wind energy engineers. So mostly we have engineers in renewable energy that have a bit of expertise in this thing, but we don't have specific engineers that were solely trained in wind energy. So it was really hard for me to start because I had nowhere to start from. I literally had to rely on YouTube to build the turbines and to get a lot of information on how wind energy works and everything else. So I think this is also the narrative in many of the African countries. We do not have the right expertise to do this. So you find that whenever there's a project in wind energy, you are basically exporting technical expertise from outside the continent, infrastructure, technical expertise. You're importing these things, and that comes at a high cost, um, and that translates to a high cost of installation of of uh, of the structures. So the third point that I mentioned is high cost of insulation. So all those 2 points, lack of infrastructure and lack of technical know-how, contribute to the high cost of installation. So we're importing everything. We're importing equipment. We're importing technical know-how, and that increases the cost mm, of implementing these projects and maintaining them in the long run. So the other challenge was high investment risks. Um, so if you compare the average consumption of uh, household, the average electricity consumption of an African household to, let's say, a European or an American household, there's a really huge gap. So this is also a challenge because investors are looking to sell electricity. They want to sell electricity. They want to generate electricity and sell it to a large market size. So now the biggest problem is when they come to Africa, a lot of households do not consume that much of electricity. They don't use electricity for cooking. They don't use electricity for heating water, for a lot of things. So if you go to developed countries, they rely 100% on electricity for everything. So there's a high risk in investing uh, in energy projects in Africa because of things like that. The demand for electricity is quite high, but then the consumption itself. Next slide, please. Yeah. So how would the government and stakeholders collaborate to create an enabling environment for the investment of for investors to come and invest their resources into wind energy? So, like I said, the first thing is capacity building. Capacity building, we need to have the technical know-how ourselves. We need to know how to build these wind turbines ourselves. We need to know how to operate them ourselves. We need to know how to maintain them ourselves. So that is the biggest thing that we have to do. We have to create centers where we're training engineers in wind energy, innovators, people that are interested in the wind energy space, give them the chance to learn more about wind energy. How do you build wind turbines? How do you diversify wind turbine designs? How do you improve wind turbine designs? Um, I think I just got lucky because in Malawi they just installed a something they're calling Unipod. It's a sort of design studio, but quite big, where you can actually build anything you want. You can design and fabricate anything, either it be metallic or plastic, any sort of design that you want, you can actually make in that studio. So I think that comes a bit handy uh, specifically in the field of wind energy, where you need to do a lot of research on turbine efficiency, on the turbine design as well. So capacity building comes first for me. You have to enable people to have the technical expertise uh, to build wind energy technology, and also infrastructure development. You want to build a wind turbine, but you do not have the fiberglass to build the turbines themselves. Now you find that you're importing um, fiberglass from China or America just to build the wind turbine blades. So if we have factories that are building, that are making steel, if we have factories that are making fiberglass, if we have factories that are making motors, it's going to be a little bit easier uh, to invest in the wind energy space, because now all we're going to need to is assemble these things in one space, instead of having to import this and that. So infrastructure development is also a key thing uh, that governments and stakeholders need to focus on to to attract investors in the wind energy space. So another thing could be subsidies. I think this is already happening in Malawi. Um, and solar energy is basically subsidized. Anything that has to do with solar. So the solar panels, the lithium-ion batteries, any electronics that are coming uh, that are a part of a solar system are actually subsidized. You don't pay tax when you're importing them into the country. So subsidies like that create a more attractive environment for investment into energy technologies like wind energy. Another thing is de-risking wind energy projects. So, like I mentioned, there's a high risk. Wind energy projects at large in Africa come with high risk. That's largely because of the low consumption of electricity in households, as well as the lack of the technical expertise as well. So there's a lot of politics that goes into this. It has to do with political will, policies that create an environment that reduces the risk in wind energy projects. Talking about taxes, maybe lowering taxes as well, subsidies, and also doing feasibility studies. Um, there hasn't been that much feasibility studies in Malawi in the wind energy space, but I'm glad that there are a lot of companies that have grown interest to do feasibility studies in wind energy. And like I said, in the northern part of Malawi, there's a company that's doing a feasibility study there, and they calculated that you can generate up to 50 megawatts of electricity. So these feasibility tests provide more information to investors on what to expect if we invest money in Malawi. Uh, what can we get in return? How much electricity are we going to generate? Who's going to buy electricity uh, from us as a power producer? So things like that, and also things like independent power producers. So in Malawi, uh, it hasn't been very recent. I think it's only been 6 to 7 years that the government created an environment where you can become an independent power producer to generate electricity um, independently. We initially we had one company that would do that, that would generate electricity and then distribute as well. So it was dissolved. So the one company became the producer and the other became the distributor. And when that happened, they created an environment where you can have investors invest in other companies to solely produce electricity and just sell to one company that's distributing. So that's just an example of de-risking wind energy projects. Um, is there a chance? Is there a potential for wind energy in Africa? Yes, there is a potential. Like you said, there's over, what was that, 91 gigawatts? Is that? I can't hear you.
it was 59,000 gigawatts.
Yes, exactly. So there's a really huge potential in Africa. But these are basically the biggest things that governments and stakeholders need to look at: capacity building, infrastructure development, and de-risking wind energy projects as well. Let's move to the next slide. So the this last part, I want to talk about the community participation, social economic benefits that come with wind energy projects. So that's me in the picture. I was working with secondary school students in a community where I want to implement my project. This we basically want to install a 20 kilowatt microgrid in this rural community with that turbine that you're looking at. So when we develop the final project, we are looking to now install a 20 kilowatt microgrid in this community to generate electricity and then distribute to households. So this is a secondary school. I was having a chat with the students, and I was actually teaching them on the basics of wind energy, how my technology works, how wind energy works, and the benefits that it would bring to their communities if we implement the project in their community. So this is just a part of community acceptance. People get to know you, they get to know your technology, they get to know what you do, so that when you come with a project, they are willing to help, they're willing to participate, um, they're willing to take roles in planning, they're willing to take roles in employment, and just to push the project forward and have it implemented successfully. So this is just one example of community participation in wind energy projects. Now coming to socio-economic benefits, there are a lot of socio-economic benefits surrounding electricity generation, wind energy generation. So electricity is a basic need. It drives the economy. If you have electricity in a community, you have businesses that are booming. So one common term in specifically mini grids is productive use of energy. This is basically where you're introducing businesses that are tapping into the power that you're generating to run. So you're providing electricity to communities, and communities are able to build businesses around this energy access. Businesses like TV showrooms, you were talking about shops, barbershops, mills, cold storage, where farmers can store fresh farm harvests. So productive use of energy has a really huge benefit for communities, where they can improve the economic state of the community and improve the circulation of income. Um, we also have things like clean cooking, where you provide incentives for clean cooking, like electric cooking utensils, to provide an alternative for rural communities, mm, so that they drive from the conventional biomass fuels for cooking to electricity cooking, and to reduce the consumption of firewood and charcoal. So this is just a brief outlook on the energy space on wind energy space in Malawi. There hasn't been any energy projects implemented yet, but we have prospects in the wind energy sector. That maybe in the next 5 years we're going to have a booming wind energy sector in Malawi, with entrepreneurs like me and also other young people that I know that are working in the wind energy sector, building their own wind turbines as well. So in the next 5 years, I am very positive that Malawi is going to be in the forefront of driving wind energy in Africa. Thank you so much.
Thank you so much, Madalisto, for that amazing presentation. I think one of the statements that has really resonated with me is the importance of electricity in electricity access to African households, especially for them to use in cooking, in lighting. And I think you showed us a few wind turbines, different wind turbines from what you have, some in the Archimedes, others vertical axis. So maybe you can tell us how does your design make your wind turbine better for the African people?
Can you come again on that one?
My question is how do these wind turbines, comparing your design with the others that are out there and already existing, how does this one become better for the African people to allow them to get access to energy?
Okay, so like I mentioned, my design was specifically designed for capturing energy at low wind speeds, not high wind speeds like the conventional three-rotor blade design. So the advantage of this is that you can install the turbine in many places across the African continent, and you don't need to place it at somewhere 100 meters or 200 meters above the ground to get maximum wind speeds. You can put it somewhere 1 to 5 to 10 meters above the ground to generate substantial amount of electricity that can be distributed to households. So it's not power that's in the ranges of megawatts or gigawatts, but it's enough power that can be distributed to households to provide their their daily basic energy needs. So it's like how mm, solar systems work, where you have a home solar system and you install it in a household, and it generates minimum amounts of electricity for powering. Only that this can actually generate more electricity for lighting, cooking, and many other activities that require electricity. So the advantage is that you don't need a lot of investment into power generation to get this thing running. You need it's a low cost technology that can be installed in many parts of the African continent.
Thank you, thank you. I'll take one question from our participants, and Collins here is asking, what are the economics of wind power access for the poor and the very poor in Africa?
The economics.
Of wind power access for the poor and very poor in Africa?
So that's very tricky because wind energy has not gained that much traction uh, for it to be scaled down to rural communities or very poor people as compared to solar energy. So solar energy has been scaled down to the smallest unit that you can install in a household, and you put it on the wall and it can generate very small amounts of electricity. Um, a very small amount of electricity for charging phones and for lighting as well. Um, the, there's been investment into small wind turbine designs like the ones I showed you, even smaller ones that can be installed that can be used for what's this standalone installations to install in households to generate small amount of electricity that can still meet the basic energy needs of a household. So, but there hasn't been that much interest in investment into these things. So there is a lot of interest in solar energy. Wind energy is largely neglected um, across the continent. That's the biggest problem.
So maybe you can tell us, how do you think that more people can be maybe opened up to accepting wind energy as a sustainable energy and actually installing these devices and wind turbines within their households to now develop the electricity?
The thing is to have a lot of, like I said, uh, capacity building, train people in the wind energy space so that they're capable of making these small units of wind turbines that can be tested and tried in households. So The good thing is solar energy is widespread. It's everywhere. You can literally just import a solar system and install it in a household. If you compare it to a wind turbine, you have to import a wind turbine from China and then come to your country. It comes with a very high cost to import that as well. Then you need motors as well to connect. It needs a lot of technicalities to actually get this thing up and running as compared to solar power. So the best thing is to actually decentralize production of wind turbines instead of having to rely solely on importing wind turbines. We need to have the capacity to build these wind turbines ourselves. That way we're going to minimize the cost of manufacturing as well as the cost of the installation, so that they can be as affordable. They can be so affordable that you can install in a rural community and provide electricity to households.
Thank you. And so we also have someone asking, do you have any resources or articles on mini grids in the Malawian context? And I also think you can respond to this as to how maybe if somebody wants to install the technologies that you've created, how do they say get the designs to actually start the work in their own backyard if they may?
So we have about 2 mini grids that are running in the country. I think one that's about 125 kilowatts and one that's about 25 kilowatts in capacity. No, 25 kilowatts, but then it's below 100 kilowatts. So it's the common narrative of mini grids. Mini grids are not financially viable anywhere in the world, especially those that start from 1 megawatt below. So there's a challenge of consumption. Like I said, if you're installing a mini grid in a rural community, you should expect that you find a challenge of consumption of electricity in those households because they don't have television sets, they don't have electric cookers, they don't have irons, all these things that consume a lot of electricity. So, like I said, there is a phenomenon. There is a common narrative that's called productive use of electricity, where you introduce these things like electric cooking in communities. You sell these TVs. You provide incentives where people can start businesses in communities um, to consume a lot of electricity so that you can run the mini grid profitably. But it's still a problem. I still haven't seen somebody talking about a success story of a mini grid that they're running a mini grid that's profitable, that has broken even, and they're able to generate profits from it. So we're yet to see that happen. But as of yet, mini grids are not that financially viable. And also the question on the technology itself. So at the moment, this is a patented technology that is solely owned by the Argentine and Malawi partnership. We're not yet open to providing the technology to other people to develop it. But with time, as we start mass producing, we will start. We'll open up the technology for other people to have access to it so that they can manufacture it and have it developed in their countries. But at this moment, it's a closed technology.
Thank you. Thank you we are hoping to have more investment and have more grids, more implementation of wind into the grid. And so John Wu here is asking, what amount of power are we looking at here from the helix wind turbines that you've developed?
So we're developing a wind turbine that can produce about 3 kilowatts of electricity. So about 3 kilowatts, and if we're going to install it in a microgrid, let's say it's a 20 kilowatt microgrids, we're going to need to install about 7 of them. That's adding efficiency and other things as well. But one 3 kilowatt turbine should be able to power about 10 households. Considering the consumption rate of electricity in Malawi, that's substantial to provide electricity to up to 10 households, because mostly households use electricity for just lighting and just cooking here and there, watching television, ironing, and things like that. So one turbine can serve up to 10 households. It's possible.
So in your presentation, you mentioned that you piloted this project, the Mpepu wind turbine project in a school. And maybe what results have you actually received in those areas in terms of energy efficiency and lighting up the community?
Can you come again on that question?
I'm saying we've seen you mentioned something about piloting your project in a school, and I just want to get a view of what sort of feedback have you gotten from the people that have now gotten access to electricity that did not have before?
Oh, no. At this moment, we haven't installed the turbine at any institution, but we've only tested it with a motor to see how much electricity it can generate, the potential that it can generate. This pilot is something that we want to do after we develop the final product, because we have a prototype, and now we're working on developing the final product, which we're very positive that we'll have a final product by February or March, and that's something we're going to then install in a rural community. We want to put that in a 20 kilowatt microgrid. Yeah.
Okay, thank you so much for that presentation. I think from now I'll just take another question from Patricia, who's asking, what plans do you have to improve the electricity consumption behavior?
You said what?
What plans? We're taking a question from Patricia, who asks, what plans do you have to improve the electricity consumption behavior?
Yeah, so to improve consumption of electricity, we are going to implement incentives for productive use of energy. Like I said, productive use, where we come to a community, and then we not only provide electricity, but we're providing businesses as well. We're providing equipment for barbershops. We're providing equipment for storing farm produce. We're providing electric hot plates as well for cooking. We were installing mills in the community where people can have access to these services and utilize the electricity that we're generating. So yes, that's the strategy that we want to approach with.
Thank you so much, Madalisto. So at this juncture, I think we are coming to the end of the webinar. And before we close, I think I'd just like to introduce you to our Switch On Africa campaign that we are currently running. And the Switch On Africa campaign is aimed at catalyzing investment in renewable energies, improving access to the grid, cutting the cost of power to boost household access, and protecting African forests through sustainable energy practices. So the objectives of this campaign is actually increase Africa's electricity consumption to between 5 to 10-fold by 2030 by catalyzing massive increase in investment in clean energy technologies, and that is solar, wind, geothermal, and nuclear by Western development partners, and to lift Africa into prosperity by powering large-scale industrialization through constant availability of electricity, by urging African governments to include nuclear energy in their energy mix to reduce the cost and electricity, and to save Africa's forests by reducing household dependence on biomass fuels like charcoal and wood. So at this juncture, I'd like to let you know that the recording to this webinar will be shared on our YouTube channel, and we invite you to actually visit the channel and subscribe, like the videos. We'll also be sending the webinar recording and the slides to your emails after the webinar. So thank you so much. At this juncture, I'll ask Ian to share the video one more time, then we can close the meeting. Thank you.
Right. Thank you for inviting me to speak.
Switch on Africa is not just a campaign, it's a rallying cry. It's a call to every individual, to every community and every government. Let us stand together, hand in hand, and light up this continent. But it's not just about watts and gigawatts. It's about ending deforestation, protecting our rainforests, and restoring our ecosystems. It's about greening our cities, ensuring prosperity through climate action, and delivering not just on our sustainable energy, but improved livelihoods for every African.
So thank you, Ian. As he loads another video, I'd like to request that we switch on our camera for one photo. As we wait for Ian to switch on, to put on the next video. Please, let's just switch on our cameras for one photo. I can see a few.
You can wave or say something so that we know you're interacting with the, I don't know.
Thank you. It's so nice to see you. So please, let's just say goodbye. Thank you, Madalisa, for that wonderful presentation. We hope to see more here, and Ian has loaded the video, so let's go in.
Obuzibu obusooka bwakubeera nti amasannyalaze gatusumbuwa mu kuvaavaako.
Ebyuma bagamba bitwala nnyo amasannyalaze ebya chipusi n'enkoko, kati awo mba sisobola kubigula nga amasannyalaze ga bbeeyi.
Kati obudde buno ndabisa TV na ttaala.
Mu lunaku gasobola obutabeerako olunaku luno ebiggwako olw'emisana, olumu ne gamala ennaku nga bbiri nga tegannadda. Sola ne tuziinaako, ne bwe zaalibadde kweziri ziyinza tuyambako mataala gokka.
Akageri gy'ebintu ekozesa baatule eyo nga sola. Baatule etuuka yo nefa, ate olwo olina kunoonya ssente zigula ndala. Kati ate yo bw'eba efudde balisobola kwatisa mataala. Mwana waba wakusoma kitabo aba tasobola kusoma aba takirako.
Twalibadde tukozesa generator, naye generator esobola okulwaninga ebyuma bino mashini zino. Eba nnene nnyo era baya ssente nnyingi nnyo.
Chipusi nzifumbisa nku, naye ng'enkungulangule.
Enku bwe mba nga ngenze kuzigula akanywa katonotono era bakaguza 5,000, 3.
Olusekese nze engeri gye nkola emisana lukola olunaku lumu.
Oluku tetuganye luwoomesa emmere, naye nago bwe mba nga funa mba nsobola okugafumbirako nga bbeeyi ebadde nsana.
Engayo kositi eri mu siringisi nga 3 per unit.
Masannyalaze nandibadde ngamba bwe nti ne bagakendeezaako ebbeeyi ne tusobola okugakozesa.
At least oyinza okukola naawe n'ofiisaako.
Thank you, Ian. I see we are right on time. So we'll close the webinar at this time. Thank you so much for coming. And we'll be sending the recording later on after the session. Thank you.
Bye.
Bye, Madalis.